This video will be about integrals that are of the form e to the x or a to the x. And the nice thing about these is that these are pretty straightforward. Remember that the antiderivative of e to the x dx is just going to be, well, the function that gives you e to the x as a derivative is the same thing. So it's e to the x and then plus c. And then remember that the derivative of a to the x is similar, so it's a to the x, then we have that natural log of a come out with multiplication. When we integrate, because we're going backwards, the integral of a to the x dx is going to be a to the x, but instead of multiplying by the natural log of a, we're going to divide by the natural log of a. And so the integral of a to the x dx is a to the x divided by natural log of a plus c. So these are the two main integrals that we're working with. Most of the variations, therefore, come with u substitution. So if we're going to integrate e to the 3x plus 1 dx, usually our u is going to be the exponent of the exponential function. So in this case, a good candidate is 3x plus 1. My du is going to be 3 dx. So I'm going to have to doctor with a 3 and counterbalance with a 1/3. So I'm going to have 1/3 integral and then e to the u, since I replaced it, and then the 3, let's see here, the dx and the 3 get replaced with du, so we're good there. And then I can integrate, so I'll have 1/3, and then the integral of e to the u is e to the u plus c, and then I can replace the u back with x. That's my last step. So I'll end up with 1/3 e to the 3x plus 1 plus c at the end, and that's it. It's pretty straightforward. You can always check your result by differentiating again. Most variations with e or a to a function, again, are u substitutions. So again, what you're looking for is you're looking for a function and something that might look like its derivative. So in this case, again, a good candidate for u would be the exponent, which is sine of x, and then our du is going to be cosine of x dx. So then I can replace, I don't even have to do any doctoring or counterbalancing. I'm going to get the integral of 2 to the u, and then the cosine of x dx gets replaced with du. So I have integral of 2 to the u du. This is a basic integral, so this becomes 2 to the u divided by ln of 2 plus c. And then to substitute back, all I do is just plug in sine for u. So I get 2 sine x divided by natural log of 2 plus c at the end. And again, you can check by differentiating. Sometimes the trick where you let u equal the exponent doesn't always work. This is clearly a much more complicated integrand because we have a fraction and not just e to stuff. So we have to be a little bit clever. Can you see a function and its derivative here? I can, but that's because I'm the teacher. If you look at this and you stare at it for a while, you eventually will come up with a u substitution of 1 plus e to the x. And this is a good substitution because our du is the derivative of 1 plus e to the x, which is e to the x dx. Oh, well that's very nice, because now the bottom piece here is the u. I have 1 over u on the bottom, and the top part, the e to the x dx, that is my du. So I really just have 1 over u du. And this is a basic integral. This is natural log. So I get the natural log of the absolute value of u plus c, and then all I have to do is substitute back, and so I get natural log absolute value of 1 plus e to the x, plus c. And you might see this answer rewritten in a multiple choice question because 1 plus e to the x is always positive because e to the stuff is positive and adding 1 keeps it more positive. So you might see this as having dropped the absolute value signs because they are redundant, but this would be your final answer, just like that. So that's an introduction to integrals of this form. Pretty straightforward. Have fun.